Alright everybody, welcome to another video, this one on Pythagorean Theorem. We're going to open up with this as we start to learn about right triangles and many things about them and how we can find missing parts of those right triangles, and why that might even be useful. But we're going to start off today with something that may be a review for quite a few of you, but I know is not a review for all of you, because there were some people early in the year who indicated they had never seen this. So what we're going to be talking about here is Pythagorean Theorem. And Pythagorean Theorem is really useful when we're finding missing sides in a particular type of triangle. That type of triangle is a right triangle. And what makes it a right triangle is exactly one of the angles is going to be a right angle. The other two are going to be acute, and one of them is right. So that makes us have a right triangle. And as I said, the Pythagorean theorem is used to find missing sides in a right triangle. So that's useful information. Now, in a right triangle, there are two types of sides that we have. One type is the two sides that make up the right angle. Those sides are called legs. I don't know why I'm using the fancy L here, but I am. So those are legs. The side that is across from the legs, the longest side of the triangle, is called the hypotenuse. Hypotenuse. So that's the longest side, has the longest name of any of the sides in the triangle as well. So, the Pythagorean theorem itself allows us to make a connection between the legs and the hypotenuse. In a right triangle, again, has to be a right triangle, the square of the hypotenuse is equal to the sum or addition of the squares of the lengths of the legs. Looking at this drawing that we have over here, our hypotenuse is named C, so that means that C squared, the square of the hypotenuse, is equal to, so equals, the sum of the squares of the lengths of the legs. So the legs are length A and B, and we need to square those, A squared and B squared, and it's the sum of those, so we're adding them together. So C squared equals A squared plus B squared. More often than not, and there's a good chance that you've heard sort of the commutative version of that, A squared plus B squared equals C squared. And that's Pythagorean theorem. You are going to want your calculators probably at this point, because some of these calculations are kind of tough to do without it. So I would grab a calculator if you don't have one, pause the video, and then come back. All right, so first problem, we're going to find the missing side of the right triangle. We need to use exact values here. So we're actually going to be approximating when we get to the answers, but that's okay. We'll talk about that when we get there. So we have this triangle. We know that this side here is 6. We know this side here is 8. We don't know the side labeled x. The missing side is, well, is it a leg or is it a hypotenuse? We can see the right angle right here, and we can see that it's made up of this side, and those are the legs. So we are missing the hypotenuse, which in our equation was c. So if we set up a squared plus b squared equals c squared, we're missing this. But we know a and b. And a and b can be really either one of the legs, doesn't really matter. I'm just going to say that a is 8, so 8 squared plus 6 squared equals c squared. 8 squared is 64, 6 squared is 36, equals c squared. 64 plus 36 is 100. That equals c squared. We need to get rid of the squared that's on the c, and the way that you get rid of squaring something is by doing the opposite of squaring. The opposite of squaring is the square root. So our last step here is that we're going to take the square root of both sides. When you take the square root of a squared, the squared and the square root cancel out, leaving you just with c over there. And over here, the square root of 100 is 10. So that means that the length of c is 10. And that problem is done. Moving on to example 2. We have a slightly different situation here. Here's our right angle, which makes these two that I highlighted the legs. Notice that this time the missing side is a leg. It's going to change what we do a little bit. So again, we start with a squared plus b squared equals c squared. Let's say that we're missing a. So a, the length of a is x, so we have x squared plus 9 squared equals 27 squared, which leads to x squared plus 81 equals, let's use the calculator for this one, 27 squared is 729. So we need to get x by itself. How do we do that? Well, we have 81 added to x, so we need to get rid of the plus 81 by using minus 81. And 729 minus 81 gives us 648. So x squared equals 648. Again, we need to get rid of the square, so we'll take the square root of both sides, giving us x equals, and the square root of 648 gives us a decimal. Remember, I would round to 2 decimal places for now, so 25.46 should be your answer. That missing leg has a length of 25.46. All right, next problem. Find the area of the isosceles triangle. Well, we're going to need to know a little bit of outside information that's going to definitely come into play later this year. Remember that the formula for the area of a triangle is 1/2 base times height. The height of this triangle is this length h here, and the base is this length here of 14. The reason that the fact that this is an isosceles triangle is important is because when it's split like this, where these sides are the same, that means that the height here splits the triangle down the middle. So that means that this length here is 7 inches, and this length here is also 7 inches. Also notice that this is a right angle. What that allows us to do is we can look at half of the triangle and use it to find the height. If I look at half of it, I have a right triangle here, a right angle here. I know this is a length of 7 inches, and I know that this is a length of 10 inches, and I want to know this length. So we can set up Pythagorean Theorem to find the height. So let's do just that. Let me extend the page a little bit. Okay. So in that triangle, we are missing the height, one of the legs. I'm sorry. So we're going to set up 7 squared. That's one of the legs, plus x squared, our missing leg, equals 10 squared. 49 plus x squared equals 100. Subtract 49 to get it to the other side. X squared equals 51. And we take the square root of both sides to get rid of the squared. And the square root of 51, x, remember, is the height, is about 7.14 inches. I realized in this problem that I replaced h with x. That's the height that we just found. So now, to find the area of the entire triangle, we're going to use the area formula, 1/2 base times height. So we'll have 1/2 times the length of the base, which was 14 inches for the whole triangle, times the height, which we just discovered was 7.14 inches. And we get an area of about 49.98 inches squared. And that's our area there. So, Pythagorean Theorem can even be used to help us find missing areas, which is kind of cool. All right, we're going to go through one more example, And then we have a little bit in the way of notes, but we're almost done. Okay, last example. A 20-foot ladder is resting against the side of a house. So we have a ladder that's 20 feet long on the side of a house. The base of the ladder, so this is the base of the ladder, it's where the ladder starts, is 4 feet away from the house. And we need to estimate how high above the house, above the base of the house, the ladder hits the house. That's our picture right there. So then we just use Pythagorean theorem to find that missing length. 20 squared equals x squared plus 4 squared, which gives us 400 equals x squared plus 16, minus 16, minus 16. 384 equals x squared, and we take the square root of both sides. 384. So we find out that the ladder is hitting the building about 19.60 feet above the ground. All right. So last thing we have is a Pythagorean triple, and it's a set of 3 integers. Actually, I've changed my mind. Pythagorean triple is something that we can come back to later. We don't have to worry about this right now. So what I would say is, for now, you can just cross this off. Not all that important for our purposes. And this one as well. Not too important at the moment. We'll come back to it a little bit later. So all I really want you to do right now is get a little chance to review Pythagorean theorem. So just make sure that you are aware of what the assignment is and you are good to start it out. Thanks for watching.